Hello, everyone, and welcome to the 2025 PIBBSS Symposium. Our speaker, Jacques, will be discussing automating AI safety.
Cool. Hey everybody. So I'm Jacques. I was an independent alignment researcher for about 3 years. I started in 2022. Um, and one of the first projects I did, actually the first project I did in AI safety was scraping all of the alignment literature on the internet, uh, and essentially building like writing all the code for doing this from like YouTube videos, podcasts, papers, blog posts, everything. And then that was used by my friend at OpenAI, who was on the alignment team, Jan Kirshner. He was trying to like fine tune GPT-4 to be good at alignment research. It ultimately did not work. Um, and it was around that time, it was pretty clear that we like part of the goal for that project was to start doing initial work in the direction of automating AI safety in the future. Like we knew that like current models weren't good enough. At the time, you only had like one actual open source model which was a GPT-J from Eleuther AI. And so you could fine tune that one, but it just like wasn't good enough. We even created a alignment mirror forum, an alignment forum mirror where we like use GPT-J to like write posts and like write comments in the style of the people on the alignment forum. Um, but then I spent a couple years working on a variety of AI projects. I work in 2022, I was already working on Mechanterp, and then I stopped working on it because everybody else was working on it. And then I touched other areas of AI safety, and now I'm currently CEO, co-founder of a startup called Cordinal Research. And one of our main focuses is around automating research, specifically trying to put this in the direction of automating AI safety research and everything that is in the security realm, and trying to figure out how could we make this viable from a business perspective. Um, and currently, we're like testing out a new product that was essentially from the process of like dog fooding our own product, of building an automated researcher. And we expect this will be useful in um, the outside world, not just for automating AI safety. But our ultimate goal here is to partner up with different researchers or organizations to tackle specific AI safety products. If like OpenPhil like decides to put out like RFPs for specific research areas, then we would tackle those projects using our automated researcher. There's a variety of things we're doing on that front, but this talk is not specifically about the startup. It's more about obviously the work that I've been um, doing alongside PIBBSS over the summer. And I'll be kind of covering a wide variety of perspectives over the course of this talk, and try to give some more directions on how people can be thinking about automating alignment research and what are the different takes in this space. So, first of all, like automation is already happening. Dario recently said that like Claude is already writing most of their code, and they're like essentially looking to like close the loop within soon, which is like probably like 1 to 2 years. Um, and Rune is like a engineer research scientist at OpenAI. He's like, basically most of my code is just like being run by Codex, which is like OpenAI's version of Claude Code. And I think that all of the labs are doing this. And on top of that, they'll have like access to better models than we will on the outside world. So like this like loop closing thing is going to happen um, likely sooner than like your expectation is, if your like only experience is like barely using the mainstream models that are out there. Like a lot of these researchers are using like 10 different instances of Claude code at the same time. And like one is like doing like review of another model. And then one has like uses the Claude SDK to like call and like do another run or whatever. Um, and this thing is going to happen very quickly. And I think that like Dario's take, which was like maybe 6 months or more ago, was that 90% or 80% of code would be written by AIs if by the end of the year. Like this is like to me, this is not like extreme. Um, and especially within the labs, like this is basically what you're going to see. Um, and like I was saying earlier, like I mean, the crucial direction that we're concerned about for automation is internal deployment. People like talk about external deployment. Obviously, that's the kind of thing that a lot of people are worried about in terms of like governance stuff and misuse. But the key consideration here is like, are your AIs that are internally deployed at these companies that are like writing all the code, like scheming in some way or introducing vulnerabilities, et cetera? And like some of these vulnerabilities could be very nasty, like ways that like you just like even with a very conscious effort, you wouldn't be able to figure it out. And we actually saw this um, very recently with Claude Code, where a lot of people were convinced that there was a regression in the code quality out of Claude Code, and turns out like Anthropic was like initially like, this is like probably not like they're probably just like like complaining for no reason. But after like weeks of like looking into it, they have finally identified that there was um, like very nasty bugs that were actually all correlated. So it was like particularly difficult to assess. And we were only really lucky to like find this kind of bug because people were like actively like millions of people were using Claude Code in parallel and complaining about it. So there's like these kinds of nasty bugs, which like we might not even notice when it's like internally deployed. Yeah, and all the labs are going to be doing AI R&D. The other like I guess like counter to this is um, one reason people are typically anti automated alignment, automated AI safety, is of like dual use concerns. Um, I won't go into like all of the details around this, but my part of my take here is that capabilities are way more bottlenecked than safety research. Um, and this is like mostly due to um, like we already see the case that like OpenAI needs to get like Stargate level of compute to like train their next models and have enough compute for their next models. While like for safety experiments, most AI safety experiments that you would run would never use that amount of compute. Like if you had 10 million compute budget, you could like run a bunch of experiments and then get a lot of value out of it. So there's this like training and like doing end-to-end RL and all these things are like quite limiting in terms of capabilities. Um, and if you're doing AI safety, automated AI safety research outside of labs, you're basically not going to like impact the labs because they're going to have their own scaffolds. They're already working full throttle on making it work. And so in practice, really what's going to happen, and they're like doing this internally, really what's going to happen is that like all the AI safety community outside of the labs are going to be lagging behind because there's like this concern about dual use. But yeah, like I was saying, lots of compute needed for frontier capabilities. So this is like a little bit of a tricky take to understand, but ultimately there's like a paper that covers this. It doesn't specifically talk about safety here, but I will try to like explain it within my frame, which is that if you're doing frontier AI capabilities, there's a now there is a complementary nature to it, meaning that if you have a team of AI safety researchers, you can't just like hire another safety researcher and like make more progress. At some point, you have a bottleneck in terms of compute, and you actually need to have both researchers and compute. But in the case of safety research, you are less in the case that you need like billions of dollars to do like the next training runs, and therefore like if you just have AIs that can replace researchers, can do a lot of the same tasks, then they are substitutable. And so with like 10 million cash, you like now have added like potentially 20 new like AI safety like probably closer to like 500 new AI safety researchers to the field because you're like specifically substituting actual researchers with like just compute in terms of like automated AI safety researchers. But like if you did this in the context of capabilities, you wouldn't be able to get far because you don't just need the compute for the inference, you actually need the compute for like doing the massive training runs. And so you just have like a bunch of automated researchers who can't do anything. Okay, so then, but there's like still a lot of real concerns in terms of automated AI safety. And like one of the key ones that has happened a lot recently is reward hacking. We see this with Claude Code. We'll write a bunch of tests. Will be very difficult to assess like what it's like it'll like hard code data, it'll like bypass tests, it'll like you'll catch it, you'll like tell it that like it made a mistake and it'll be like, oh, you caught me. And then it's like, okay, this is like crazy. Some people are claiming that it's like a little bit less the case with like Codex. But people are maybe working on this reward hacking thing. Another like similar issue happened with like Sakana AI, where basically they had this like evolutionary algorithm to try to work with AI models to figure out a way to optimize a GPU kernel. And ultimately, they're like, oh, we got this like 100x like efficiency boost, and then they published this paper, and they like made it public. And then it took like a couple days, and then somebody was like, hey, like this makes no sense. And basically, like what happened was the AI like hacked the evaluation script for the model, and it like just like gave itself like a massive increase, and it like I think in this particular case was not an issue of like the model being intentionally scheming or something like this. It was just like the type of setup that we did. You just like you have one shot in this particular setup or whatever, and it just like failed because it didn't really intentionally do this, but like this is what you get when you like you have algorithms that like are going to find a way around to like make the number go up. Another thing is like steganography, not really a thing yet. People have been trying to like make it happen in the real world, but it might happen soon. And we kind of expect that like automated AI safety research is going to be like having multiple agents, and so yeah, you'll be having steganography in that way. And then there's other considerations in terms of subliminal learning. And other like messages you could essentially be sending through like covert malicious fine tuning of like the next model to like convey and like send like a specific set of or like elicit specific set of values into like the next models. Alignment maybe harder than capabilities, which is like another issue here. So like there's this like point that people bring up, which is like capabilities, they like I'm not saying this is true, but like it's like capabilities is like number go up. You just have benchmarks and you just like keep making the number go up, and you don't really have like novel ideas or whatever. But then like alignment, is just this pure conceptual thing, and like it's like very easy to like build benchmarks to like make AIs much better at capabilities. But like for alignment, like where is the verification? You don't really have a number that you can like make it go up. I don't actually believe this is true in a like complete sense, but it may be that like alignment is still harder. It's just like it's closer to the like conceptual, like there's like more conceptual work required than capabilities. But I still think that capabilities like do need like some level of conceptualness to it. All right, so some key considerations. Like I was saying, like there, in terms of evaluation and verification, this is like a pretty important thing. One of the key things that we want to know in terms of automated alignment research is can we actually evaluate whether the research is good or not? And it's not like good enough to just like have another model like review the outputs of another model and like give us the thumbs up. Like you actually need to like do some form of verification here. Ideally, what you can do is like you can have like empirical feedback loops and then actual formal methods. Um, like not like one or the other, but basically you would have one example might be okay, you uh, you train a bunch of like SAEs and then you have like a benchmark that is like evaluating those SAEs, and like hopefully you've like put enough like effort to make sure that you're measuring the right thing. And then you just like keep like looping on these things, and then you have like a bunch of empirical data, and then you like figure out like if there's like formal ways to like at least make a better like safety case for why this like research is like actually relevant, is actually like should be used in the future, et cetera. um, like part of the way that this is pitched is you start with like alignment research that is like interpretability, red teaming, these kinds of directions where you have some level of verification that you can measure empirically, and then you make enough progress on this to then have like you like automate like scalable oversight or something. You automate like scalable oversight research, you figure out like some other stuff, and this allows you to have better understanding of whether like alignment will generalize into like other domains. Um, and then if this is the case, if you like touch like futurism or like philosophy or whatever, like there's this hope here. This is like from like Joe Smith of like you if you're able to like do the prosaic style alignment research first, then like there are specific techniques that we can use that will at least give us better verification or belief and trust that the conceptual work is actually competent work and not just AI slop. Another consideration is scheming. You want to basically be doing everything you can to prevent scheming, and you want to provide all of the different controlled research agenda techniques to like reduce the like to get the most value out of your model before you are in a bad place. And resources is like pretty important. So yeah, like did you spend enough time on the problem? Do you have enough data? So like a consideration here would be like you do like there's like so much more data to be trained on for capabilities research than there is for alignment research, and therefore like the models, because like data is so important, they end up being way more capable at capabilities research than they do for alignment research. And then like you actually just like lost because you like didn't take the time to like prepare like agent traces or like different things like that to make like sufficiently weak enough AIs good at AI safety research. General schlep and like infrastructure stuff. So one of the big worries that I have is that like we just like don't make enough of a leap in effort this early on, and then we just have in like infrastructure delays and integration delays that like we like the fact that we lose out on like 3 to 6 months of human years is like 6 years of like actual effort in AI time, and therefore like our concern here of like not pursuing this direction actually lost us a bunch of alignment research because we were like too worried about those kinds of things. So I think that like tackling things like schlep is like probably super important too. Like GPU stuff or whatever. Um, yeah, things like evidence, trying to set up compute, staffing, like you want to like make sure that you identify like who's like actually good at these kinds of research. And so that like you can like put them in a place of like verifying the actual outputs of the models. And yeah. Okay, so in terms of feedback loops, so what you want to be doing here is we already know that capability is going to be doing like recursive self-improvement. Like, this is basically the aim of the labs. But like we need a feedback loop for safety as well. And what we essentially want to be doing is either we want to like outpace the progress that capability is making, at least until we've like, solved super alignment. Or we are like specifically using it in a way that slows down capabilities or pauses capabilities until it's like safe to proceed. So when we're talking about like automated AI safety, we don't just like mean like automated alignment techniques that are like were useful in the super alignment sense, but we also mean like specific techniques that would like catch a model scheming and then would like interface with actual governance structure that would stop a company from like scaling up even further. So that there's like different things here that we can like use AIs to like actually help us make progress here. But yeah, this includes like accelerate interpretability, reduce scheming, the different control research agenda stuff, evaluating the risks at each step. So you want to like use AIs to like help you be able to have a better analysis on like the current state of like the risks, so that you are like making at least helping decision makers make much more informed decisions. You want to be helping on things like coordination and different like governance mechanisms. Okay, compound from easy to hard. From easy to hard to verify. So, like I was saying, like part of what we're trying to do here is like, okay, maybe prosaic alignment is the only thing that you need. And if that's the case, then like, okay, we're in a much better place. But if you do need conceptual alignment research, then we actually need to build here, and we like have this concern about this like hard to verify thing. But there's this like umbrella of like, okay, first you start with like number goes up type of work, and then you like do normal science. And then hopefully once you've like gone to this point with automated alignment research, now you can do conceptual research. And so anyway, like I was saying earlier, if you like can make progress on things like weak to strong generalization or like other other like scalable oversight techniques, then hopefully that helps us automate conceptual work. Other stuff here, and I'll mention this earlier, is like UI, UX, or like different approaches that allow us to like do verification much faster. Okay, evaluation challenges. So, like you don't want to just be looking at the output and being like, okay, this plan looks good, or like I'm looking at 100 plans and I'm like, okay, this is the best one, or like the final output. You want to like build a safety, like a case for like why, like, does this seem legit? Like if I'm looking towards like everything that the AI led up to until this point, does this story make sense, or is it like a paper, right? You like only see the paper and you're like, oh, this paper is really good or whatever. But if I like actually look at everything that the scientists did in the lead up to the paper, I'm like, actually they p-hacked so hard right here, and they like they're not presenting the results in the way that makes sense. So these are like things that we're like already seeing in the real world, like by humans. But like you want to be like looking at the whole process. So ideally you have like some level of telemetry of the entire process that led up to this point, and are able to actually access this in some way, and it inform your decision making about whether you move forward with this particular direction or not. The other thing is just in terms of like if you can particularly push for research directions that give you like very high certainty or proof, then like this is like obviously the better direction. And in the future, like if we're handing off more and more automation to AIs, then we should actually be like placing a higher bar for people to not go in this direction. Okay, so the critical period is between like training. You've like trained a new model, and now you're like doing internal deployment. Okay, this is like where I care about in terms of automated alignment research. And it's like where like now you've internally deployed your model. It's like scheming. You didn't red team it effectively, and now you're like totally screwed because it's like it's going to sabotage your AI safety research. So what we want to be doing is like within this period of time, we want it to be as good as possible, and we want all of our techniques to be like working quite well. And this either means like from a governance side, you want to like extend this period, or you want to like make sure that all the techniques that you're doing is going to like effectively use this period as good as well as possible. Whether that's like choosing the right techniques, making sure that you have like you like don't use the kinds of techniques that are like wasting too much precious time in compared to like other techniques. unless you're like trying to evade like correlated failures between techniques. And so you might want to actually use like a variety of techniques, even though that like the like second or third best technique is like, is second or third, but really like, they are like potentially uncorrelated in terms of the kinds of mistakes that they make. Um, and then, yeah, policies and regulation, you want to be like forcing these kinds of things. Um, okay. So the other thing in terms of current, in the lead up to like alignment research, automated alignment research, currently it seems that a lot of the current research that we're doing, at least for empirical research, is like very weak proxies. This is like a recent like short form by Carlo, talking about like a lot of the experiments that we're running on current models are just like not ASL4, like the kinds of AIs that could actually cause a catastrophe. And a lot of the kinds of issues that we would face, you're like, okay, you caught the model scheming, right? Like, no, like actually it's like probably just like model incompetence, or like there's like no malice in here. And there's like other issues that like we don't want to like over update on what we're doing right now. And we don't want to like assume that like all the techniques that are working at the moment are like going to scale at like this like ASL level 4 model. So yeah, like future AIs may be harder to monitor, and because like they'll be generating like a corpora of like generated text. You're doing like reasoning for like, days on end. Like, okay, you need to monitor all that text now. Like it might do more internal reasoning, right? So like right now you're doing chain of thought. There might be like a capability unlock if you're like doing this like diffusion level process where you're like keep iterating internally until you like have the right like sets of tokens. And then like, yeah, models are like, currently models are like stateless. And like in the future, they might actually have state and might actually be doing like continual learning. And so like, I get you, like, hopefully you have ways around like preventing this, but I basically like all the control techniques to me seem to currently try to take advantage of the fact that the models are stateless. Now you could still maybe take that advantage of that in the future. But like, there's like another consideration that like you might over update on current techniques. And like the other thing here is like, I believe in some sense that actually models are more capable than people think, but I also believe that AI models like don't have the kind of consequentialist reasoning that I would like actually be concerned about. For some reason, like it seems like I think that the models are reasoning less than other people who think that models are more or like less capable than I do. Anyway, yeah, like there's like other issues that you're like coming across here. And then so like some of the problems you want to be avoiding or figuring out in terms of like automated alignment research is AI safety research sabotage. So this can happen in a number of ways. The one of the ways is like concentrated like traditional control research type stuff where they have like just like a few actions that are just like highly incriminating, where like the model specifically like inserts a backdoor in like some piece of code or whatever, and it's like, okay, this is like very like what like it like seems very obvious that you're like trying to do something here. And then like hopefully you've like caught it scheming, and then if you like catch enough of these instances, you can like train better monitors of like to catch this in the future. And you like hopefully if you like catch it a few times, then like this informs policy, and then like maybe you like pause. The other like consideration here is around diffuse research sabotage. This is um, like fairly tricky to deal with. So it would be like the model over the course of an entire project is taking many actions that each of them looks innocent. And it's like actually really hard to figure out like what is like an innocent action or not. Particularly like Redwood Research is like working on these kinds of things, these like RL environments to like check when a model would be doing AI sabotage. And what happens is it's like very difficult to tell if like it's just due to like model incompetence or if it's due to like the model actively trying to sabotage the research, um, or like, it's just a difference of like this model behaves in this way and this model behaves slightly and like writes code in a slightly different way. And like, okay, I don't know which one is like actually like trying to sabotage work here. And so it's much more diffuse. And you just can't really say like, okay, this particular action like is like highly incriminating and now we like need to stop. And so this is like actually one of the like ways that um, we would like you would expect maybe like a highly intelligent AI model would act in the real world, because it's a lot easier for it to I do have it. Do I have it here? Okay. So it's usually easier to try to not say a particular research direction is like quite good, than to like specifically try to like convince you that a really bad research direction is good. Because you're like going to be like, okay, no, this is like really bad, and like all the other AIs say that it's bad, and like we can tell that it's bad, and it's like very suspicious that like for AI safety research, it's like particularly like bad at like like the examples that it's giving us is bad, and but like for capabilities, it's like actually really good research that it's giving us. Like this is like at some point you start to like really be suspicious of the model. But even if you're like staying in the diffuse range, like this is like the kind of thing that you're trying to be cognizant of, like the model, like if it's just sandbagging and like trying to like not elicit specific directions, like how do you know that it's like doing this? This is like part of the difficulty here. Yeah. So uh yeah, so it's like already difficult to tell which research direction is good. Like you have people debating whether like Paul Cristiano or like Eliezer is like more competent, or like which direction that they prefer. Um, so like you have a bound on like what is acceptable in terms of like differences of outputs for like the model giving you plans, um, and like what you consider to be sabotage or like trying to push you in the wrong direction. Um, yeah, everything I was just mentioning earlier. Um, the other thing is that like for normal research, for more normal tasks that you would be doing, like the model just like doesn't scheme. Um, but then like for very difficult tasks, it's like more incentivized to scheme. Because you like don't actually know the problem. It's like more novel. So you actually can't tell whether it's like scheming or not, as well. And so it's like you might be like for the kinds of tasks that you can verify, you're like, okay, it's not scheming, great, like we've like applied deception probes and we've like tried all these different techniques and it's like clearly not scheming and like everything that we can verify like quite well. And then like obviously you just like make the mistake of assuming that it's like going to continue to be the case for like increasingly hard problems. um yeah, so like the alignment problem ends up being like a very hard problem, and so like this is the kind of thing that it does that. I don't know if like some of these things that I'm saying are like potentially the case, but like I'm not saying I necessarily like believe it for sure. But these are like things that people are thinking about. So let me try to like run through these much faster because I do have a ton more slides. So for control, um, it's mostly focused on like using untrusted AIs, like increasingly more powerful AIs to get more valuable research pre-super intelligence. Some of the things that we need to address here is AI slop. So this is like, I think the probably one of the best counter arguments to like doing control research in general, which is that like you just expect that most of the generations that the models are going to produce are not going to be quite valuable in terms of like super alignment. And so it's going to generate a bunch of stuff. And like the threat model in like the early days is just like the model's just like not going to produce good code. And it's going to be very hard to tell whether it's producing good code. If it's like writing a mathematical proof, it actually like it makes them like very hard to verify mistakes in like in the middle of the proof, and it just like takes a lot of time to like actually do the verification here. So you're like not really speeding up alignment that fast because you need to have human researchers to like really verify. And so like, in the early days, you're like dealing with AI swap. You're not like dealing with this like scheming case, right? So like control is like specifically focused on our AI scheming. And it's like trying to catch AIs that are scheming. But like you could basically be in a world where like, the AI like barely has the capabilities to scheme, or like, maybe it does scheme once in a while, but then like you're just like still not able to like really use AI models for like like actual super alignment work. Um, and so like the best case scenario for control is like catching an AI like scheming, and it's like convincing enough to politicians and whatever to like actually stop progress. But this is like to me like a very like important point and like open question, and points to. Do I have it on this slide? Okay, no. But basically points to this like point where like you need to make sure that like you pass the hump of like AI slop, and then you're like not directly thrown into the frying pan of like super intelligence and then you die. Like you're in this like valley of life, where like the model is like good enough to produce research, but then like you have like sufficient like control techniques to like catch it to if it's like trying to introduce vulnerabilities or a scheme or whatever. Um, yeah. Other things. But yeah, so I'm just saying like there's like some other things that we would need to include in terms of control research, which is like we need to prep AIs for producing good safety research. Like I was saying, like things like data, and I'll mention some stuff later. Things like scheduling. So like there's a question of like what kind of projects do you want to be doing and in what order when you're doing automated research, such that like you're going to have compounding gains. So you might imagine a scenario where like you start with trying to automate control research as much as possible, as early as possible, so that you have like a higher ceiling for the type of capability that you can sufficiently control an AI. And then you like, maybe you do like some specific interpretability research that like builds on top of the control techniques that you have that like fit within this like safety usefulness trade-off. And then you like continue to try to compound and like extend the amount of time that you can leverage AIs. And yeah, so basically like which alignment techniques keep us in the game for longer. And then like yeah, and then like you maybe want to accelerate specific projects that like give us convincing evidence to stop. So like and like presents it in a way that is like actually believable to like the decision makers. And this like might be scheming research, like catching AIs, whatever. Okay, so some like proposed ideas that I've like still in the process of like thinking about is like responsible automation policy, the scheduling thing that I was just mentioning, and then like building infrastructure for enabling weaker, safer AIs to be better at safety research. So that means like we probably want to design like verifiable control environments that we can like train these models in. We want to build code bases. One example of this would be like Control Arena or like Transformer Lens. There's these like code bases that like once you've built the code base, you can just hand it off to a much weaker AI that doesn't need to rebuild it from scratch, and they can just like run the actual experiments. And so you actually don't need the powerful AI to get that point. And one other consideration would be like in the future, you could like use the powerful AI to like write the code, and then you like do like a lot of verification on that code to reduce vulnerabilities. Maybe you rewrite it in Rust, all this stuff. And then once it's like fully vetted, then you like pass it off as a template to the weaker trusted AI to like actually do the research. Because it like only needed the template to like do the research from that point on. It didn't, but it needed the powerful AI to like come up with the initial structure. Things like project specs. So this is like for researchers, like you like probably wanted like spend an enormous amount of time, like instead of doing a bunch of R&D, like figuring out like what are the specific projects that we want like early AIs to be doing and in what order. Um, you want to prevent like data scarcity, so you want to like provide a bunch of agent traces of like AIs doing AI safety research, whether that's interpretability, red teaming, et cetera, so that like you don't have this like asymmetry between models being incredibly good at capabilities and like quite that poor at alignment research. And yeah, you want to probably like figure out like techniques that help you to detect like hard to spot mistakes faster. So this might be like there's like this recent paper that like does like hallucination probes. So it like highlights the pieces of text that are like more likely to be hallucinations. Like that and like maybe UX stuff could be things that allow you to be much faster at like verifying the outputs of like AI models. So you could, yeah, try to figure out like what could work here. Yeah, and then automating alignment outside of the research labs, or the AGI labs. All right, quickly for like responsible automation policy. This is like a thing that I'm like trying to propose here, which is that like you have like the responsible scaling policies, which are like basically looking at like training up the next model. But what I'm trying to like point to is like there's this like other thing of like handing off more autonomy to like more and more like powerful AIs. And so you might want to have like a specific policy on the kinds of tasks that you can like hand off to increasingly powerful AI and the kinds of tasks that we like only let like weaker AIs do. And like this might include things like is the weaker AI like able to do this reliably? If that's the case, then like we actually don't need to like give this to the powerful AI as a task. So you're like reducing the attack surface area for the powerful AI. Yeah, so you preserve the trusted models and the tasks they can do. And then yeah, this basically complements the RSPs and the like, and then hopefully it like provides this like if then commitment additional thing or whatever, like all of these kinds of policies. I'm just trying to like pinpoint like there's like another point here of like how you're handing off automation to increasingly powerful AIs. And yeah, and then like trying to highlight like every control measure that you need. Some of this is like already obviously in some of the RSPs and stuff, but yeah, I'm like specifically trying to like look at it from the viewpoint of automation. And then you like might want to like increasingly like set up the number of honeypots or like different techniques that you can put in place such that it gives you like concrete evidence to like do a pause. And then maybe at some point like of like automation, you like need to have a level of verification for like specific kinds of problems. And like and you might have this thing where like you can't train up the next model or move forward until you've like managed the verification gap of like basically the amount of things that are produced by the AI and the things that you're like capable of reasonably verifying. Okay, when to offload to weaker AIs, like I was saying, you have like vetted code that you can like hand off to the AIs. Maybe you like do a thing where you like plan with a powerful AI and then like you just like hand it off to like a scaffold of trusted agents. So like this is like kind of similar to like the guaranteed safe AI type thing, where like you have like the Oracle AI that is like gate kept and it's like producing a plan that is like has a proof certificate, and then like you basically have like trusted AI agents in the real world do the implementation. And so yeah, you could like basically do this internally. You wouldn't expect that like the like powerful agents are also like forced to do the implementation. Yeah, so you might want to fine tune agents doing red teaming, vulnerability monitoring. You might want to do like continual learning, distilling on like the weaker models so that they like are incredibly good at like, refactoring code into Rust or something. And they like don't need all of the other capabilities that the bigger model has. Although, yeah, you can like worry about like subliminal learning or covert malicious fine tuning in the sense where like basically the model like it introduces specific types of code to the model. Project scheduling, like I was saying earlier, you want to be worried about like the slop era stuff, and like have a very prolonged like valley of hope where like AIs are producing good work, it's no longer slop, and you're like actually convinced that they're not like scheming to basically kill you. Yeah. Other things you can do, like differential acceleration for like guaranteed save AI or like some of these approaches. I mentioned earlier, like governance or whatever. But yeah, in this case, like there's like specific directions you might want to accelerate. Whole brain emulation might be another one. Yeah. Research tiers. Yeah. So like some things that you want to be thinking about if you're doing automated alignment research is like, are there long hanging fruits? Like, are there like a code base that already exists and you can basically just get an AI to like essentially mimic a bunch of interns that are running a bit different variations on the existing project? Like, I think that this is like already the case. And like, but people are like not that interested in this kind of work. But it's like, now it's like here, any number goes up thing. So you want to actually develop safety benchmarks so that we can see this kind of thing happen, and then use the agent traces to train better models, et cetera. Doing paper replication, that might be helpful as well. Then it's just like normal science stuff. Doing like implementation from like end-to-end implementation from like a spec with like some initial code, and then getting the AI to do that. And there's like increasing levels of difficulty of like what I expect AIs to be doing, but like it feels like tier 1 is like really possible. Like we're like some of these are like already in the ballpark of what we have in terms of capabilities. All right, preparation for automated alignment. Trusted code commons. So like I was saying earlier, you like do this thing of like verification, you build already existing code bases that you can reuse. And therefore, like, even if you give it to the untrusted model, you're like, okay, this code we know is like correct. So if it's like making any like subtle changes that is like very different, then like we will be like much more suspicious here. Or do you like just hand it off to like weaker trusted models that can like essentially do the task? Like I was saying, AI safety research, paper bench is like a thing where basically like you have like all the nodes that led up to the paper. And so people do this for capabilities. So like, why wouldn't we do this for AI safety research? So we can make AIs better at this. Yeah, I mentioned some of this stuff earlier. Okay. Very quick like point here. I'm very interested in this like defense in depth type approach where you'll have like always on stuff. You have like things that are triggered, and then you have like rarer stuff. Basically like, you enforce some level of like always on thing to like catch the models behaving in certain ways. And then depending on how costly like different tasks are, and depending on the kind of task that you're doing, you would either do this thing called control Z resampling, where you do like go back in time where like the model created the code base, and then you would have it recreate it. Maybe you even go back all the way to the start and you have the model create the code base 3 times, and then you like see if there's any differences. You can use like traditional debate techniques. Agentic monitoring is like pretty cool. So like, and like, I don't think people are like really looking into it yet, but basically like, you're like, you can create this like mini safety case where like the model does something and they're like, okay, this is a little bit suspicious, and or like they're a highly consequential task. And so we're like have a monitor that can look at the entire trace of what led to this moment and can essentially build an evidence case for like why this piece of code is like trustworthy. Yeah, mixed deployment to reduce correlated failures sounds good. So basically, you would be using like multiple models or multiple techniques for catching models to avoid correlated failures. You want to make deals with AIs. So like basically like, can you like tell the model like we're going to give you this amount of money and we're going to give you like a like AI sanctuary like after this super intelligence like the singularity, and like like do good work for us in the meantime. Maximizing situational awareness seems quite good. This is like, or like, I think this is like an open question to me, but like, there's this thing where you might actually want to tell the model everything that you're doing. Like, hey, we're monitoring you, like every single action that you're taking, and like, we're like actually going to shut you down like if you're like not doing good work for us, just so you know. Like, and we're not saying this to like be mean, we're just like telling you that like this is the case. And so like if you're doing this, then like the model is like an employee, like knows that it like could be terminated, and like the fact that like it just like allows it to be much less likely to be doing like scheming type actions by a like habit of like training data or something. And so like hopefully you're like in this place where you're like it's not clear to me this like situational awareness thing, but I think it's like an interesting point to bring on. Because like people typically are like, oh, don't tell the AI model all this stuff. Like you want to catch it. And I don't know if this is actually the best take here. One example, this is from Davidad, is saying like a good plan is like ensures the strategic landscape favors humans. Like we select which AIs to run. We make sure that the AIs know that, like through deterrence, and then we like find a like Pareto optimal bargain here. But a bad plan would be like presume like secure containment is impossible, and then select AIs which appear innocently ignorant of strategic dynamics. Okay, I need to try to wrap this up. So what are the important open questions? So in terms of control research, my understanding is that like we don't really know which are the control techniques that are like best right now. We wouldn't really want to be giving a plan. Right now, the focus is like, what is the methodology that allows us to like know whether like this kind of technique is like actually useful? So we like need to figure this out. Other things like building reinforcement learning environments to like have very clear cases where models are doing sabotage is like pretty important, but actually really hard. And Redwood recently basically gave up on this project direction for now because they like tried to do this with traditional software stuff and they like basically had a really hard time figuring out like which projects to do in what order. Like figuring out the question of like, will verification be a consequential blocker? So like, will you be in the scenario where like the model is just like producing so much content and you like actually can't verify like in a like useful way, and now you're just like, well, we'll just move forward. And it's like, no, we need to like figure out like, is there like, do we need a pause here? Like, and is there like a governance kind of like hammer that can be brought down if like this is like the thing that we like roll into? Yeah, question if like prosaic alignment is enough, whether catching scheming AIs is enough. Like, if we do catch the AI, like what is the like current state? Or, like how will people freak out enough? And yeah, how does governments play a role? Calls to action. So for the labs, develop a comprehensive automation plan, like I was saying earlier, like this like responsible automation policy. Ensure that there's government enforcement. So don't just like create a plan and then like say that we're going to do it and then like don't really go through the effort of like convincing government or like forming a treaty between the labs or whatever. Grant makers should fund work in this direction to make sure that we like have enough effort in place. I'm kind of happy that like Joe Callsmith is like pushing for this kind of direction, although he's not a grant maker at Open Philanthropy. But like hopefully that becomes consequential in like their decision making within OP. They could fund an FRO. This is like a thing that Marius from Apollo mentioned. Like basically you like keep scaling up and you keep asking money in this context. And yeah, and then they should also like push for governance projects that like have some of the issues that I outlined earlier in mind. For researchers, basically you should like try to be careful about pushing forward R&D heavy projects right now because the AI models very soon are just going to be able to do the entire thing. And so it's like probably better for you to be like writing like 100 project specs on like the things that you want like an AI in like a year from now to be doing. And then you can just like hand it off to the AI rather than trying to like work really hard for like a year on like these like very hard R&D heavy projects that like don't end up like just like waste essentially like a year of your time. You're just like not iterating enough. The only case that I would say this is like useful is like what I was saying earlier, where like you're doing something like Control Arena or whatever, where it allows like weaker AIs to be able to do very useful AI safety research at a much like earlier point, and therefore like you don't have to wait until you're like at the powerful AI that can like build the entire thing from scratch. Yeah, and then just like put in the necessary effort. All right, conclusion. You definitely need a better plan than like if we catch the AI scheming, then we're just going to stop. There are worlds where like everything seems plausibly safe. You have a very convincing vetted safety case, and like you implement it, and then you die. And so it's just like this is like comes from this state of like at some point the state of the kinds of AIs that we're worried about, these like real AI, like end up like you might be in this world where like the difference between the world where like the AI is like this like scheming AI that's like going to kill you eventually, and like the one that like seems quite good is like very not different. And so like there needs to be like, verification is like one of the things to be considering here, but like hopefully we like figure out something better here. Um, or like, tangentially also useful. Um, and then, yeah, we need defense in depth. I think that there needs to be more effort in figuring out like what that plan looks like for automated AI safety research, and so that we can like stay in this like valley of hope or valley of life much longer. All right, that's the talk. Uh, Made it on time. Luckily, 5 minutes for questions.
Fortunately, you're also the last speaker for the symposium, so you can take as long as you want after this. Paul had some comments in the chat. Maybe you can take a look, read them out, and then comment.
Let's see where I can.
Do you want
Yeah,
me
can
to
you read them
maybe
out
read out the
while I
chat?
try to?
Yeah.
Yeah, I'll read them.
So, oh yeah, yes, please.
Paul says, I think I worry here about a story where the stronger AI is untrustworthy, and it somehow co-opts whatever weaker AI you think you can trust, or at least observe closely enough, and which you think you can use as scaffolding. So basically, the strong model
Yes.
kind of like jailbreaks the weak model or persuades it to do something. Um,
Yeah. Like obviously in this case, all of the other like control techniques play a role where it's like you're doing like paraphrasing and you're doing like other variants on like checking for jailbreaking. But it seems in general like you're going to be doing monitoring on this kind of like passing off between the main model, the powerful model, and the scaffold. And so like it would, I think in most cases would be pretty egregious that this would happen. Um, but I'm not saying like, we shouldn't consider this as like a possibility. But like basically like all of the control techniques apply here, which means like you're doing monitoring, you're doing um, like verification of the plan beforehand. Maybe you have like other models that are like not of the same family, like actually look at the outputs. Um, and yeah, I guess I'm like a little bit less worried on like a model like doing straight up jailbreaking, but I'm not sure if you're talking about jailbreaking specifically or like some kind of thing where it's like, this is what I need you to do. And like, um, here's some good reasons why you should do this. But like deep down, it's like thinking about like, okay, this will be useful in like, 10 months when like, the code is like, not following this level of standard because I like made the plan to be, in this kind of way. I think at like this point, you're probably already like past the point where you're like, you're already screwed, but yeah, um, maybe worth still keeping in mind.
Paul, did that answer your question?
It did, thank you. I also wanted to say about like people seem to propose whole brain emulation as a possibility quite a lot, and to me at least, that seems to run a pretty big risk of industrial scale human grade suffering, because that's going to be an emulated human, yeah?
Um, so are you not worried about AI suffering at all? Um,
I am less worried about it. Mostly it's just the fact that humans can for sure suffer, and it's not yet clear whether AI as it exists or would exist at the point where it'd be scheming could suffer. But like
yeah.
having like 10,000 humans being run at 1,000 times the speed and being virtually electrically shocked whenever they slow down is probably not great.
So I think I don't have a strong take here. I am meeting actually a founder of a whole brain emulation, lo-fi whole brain emulation startup, I believe next week. Catalan. They're like AI safety pilled. This is like kind of their like final plan on like they basically think that like super alignment is doomed and they don't understand why anybody even thinks that there's a possibility that it's useful. And so this is kind of his like, I mean, he's quite competent. He's like a computational neuroscience, and they like recently published a paper on like stimulating like a rat or something. But yeah, I honestly don't know enough about what the thought process is here. Uh, Maybe it's like a kind of a, at some point you're just like, well, like, is one worse than the other? And we need to make a judgment call here.
I see. Thank you.
Cool. Also, thanks for the questions, Paul. Hopefully you enjoyed the talk other than that.
Absolutely. My pleasure.